Okay, 5-2 piecewise defined functions. Okay, we're going to skip the example. It's not all that important because when we talk about piecewise defined functions, we're talking about pieces, parts of something. And when we talked about absolute value functions, okay, think about this. We actually have two different lines, okay? Notice this line is going down, whereas the other line is going up. We have two different functions. We've got a negative slope. We've also got a positive slope. And notice where it's changing. It's changing direction when x is equal to 0. That is what's known as a piecewise function, okay? A piecewise function, okay? So let's talk about this next one here, okay? Express -3 absolute value of x as a piecewise defined function. Okay, well, I know for a fact that it's opening downward. Why? Because your slope is negative, okay? So the graph's gonna do this. And notice how it's gonna break at 0, okay? When we talk about a piecewise function, notice this. The first part, we know that when x is less than 0, it's going in the upward direction, right? Because we're actually going this way, essentially, okay? And notice how the slope is negative for the other direction. It's actually gonna be the positive slope. So it's gonna be 3 times x. And that's when x is less than 0. But what about when x is greater than 0? Okay, it's actually going downward. So that's why we need to use the original slope, okay? If you were to graph this real quick, okay, let's do this. I'm gonna pull out good old Desmos for this, okay? So let's pull out Desmos real quick. I'm gonna drag this, beep, bop, beep, up, and up, there we go, okay? So I'm only gonna drop part of it, okay? So 3x, but then when x is less than 0, does it work? I guess not, okay. So let's do that, 3x, boom, there you go. But I'm stopping right there. If I do -3x, boom, notice how the break is at 0, one's going up, then down. Imagine the red and blue together, okay? So the 3x one was when x is less than 0, but the -3x when x is greater than 0. Very important. Okay, as we move on to the next part, okay? Notice for this one here, and I'm not gonna confuse you guys too much with this. The hard part really is just making tables for this because to be honest, you know where the breaks are. Once you know where the breaks are, boom, it's actually simple. And for these right here, all you gotta do is this. What I would do, okay, let's focus on this one here. Just make a table. Okay, you know they're linear functions. For the ones that's 2 and less than 2, just plug in 2 and 1. Okay, you get 3 and 2, plot those points, draw your line, okay? For the next one, it's actually more simple than it seems, okay? For this next one, okay, I know that breaks at 2. I plug in 2 into here. 2 times -3, that's -6. That's -3 plus 6 is 3. Now I'm going to plug in 3 essentially. Okay, when I plug in 3 for x, okay, I get -9.5. Or sorry, -9, that's -4.5 plus 6, that's 1.5. When I plot those 2 points, I draw that line now, okay? You need to make your table. Once you know how to make your table, it's actually not difficult. Let's actually talk about this here. Boop, just like that, okay? So notice how the break's happening at 1, and it's less than 1, so 1 and 0. When I plug in 1, I get -1. When I plug in 0, I get -2, okay? Now let's focus on the other one. Boop, the one in purple. Okay, I'll do this over here on this side. Okay, when x is 1, the answer is 1. When x is 2, the answer is -1. If I were to draw those two graphs, it's actually not that bad. Okay, let's draw it over here on this side. Okay, beep, bop, beep, boop, bop, beep, beep, bop, boop, and boop, bop, beep. Okay, so let's do the first one in vomit green. Okay, 1, -1, boop, 0, -2, boop, and I draw the line that stops at 1, -1. Now let's do the one in purple, okay? It was 1, 1, okay? Which I believe I'm correct, boop. And then, oh, that was terrible. Let's try that again, okay? 1, 1, boop. And then 2, -1, boop. There you go. A little sloppy, but we get the idea. We're not extending it upwards and we're not extending the green graph, okay? It starts and stops somewhere else, okay? Focusing now on this example. Cheyenne's mother is reviewing the monthly water bills from the summer. Each monthly bill includes a graph like the one shown, which reflects the different rates changed. Several relatives visited Cheyenne's family, okay? Keep this in mind. We have three different ordeals. Between 0 and 5,000 gallons, boop, it's this. From 5,001 to 10,000, boop, it's this. And then lastly, from more than 10,000, boop, it's this. Make a conjecture about why your utility company might charge higher rates for greater levels of water consumption. The more that you're using, they have to charge you more because you're using more of their service. So they want to limit you into the tiers. Believe it or not, both water and gas do that. Ask your mom or dad how they charge you for the summer. The reason why it's more expensive is because they put you into different tiers. If you're using more energy, believe it or not, it's not a consistent rate of change, because after a certain tier, it actually bounces to a different price level. The more that you use, the more that you have to pay, not because you're using more, but because they put you in a different level. Very important, okay? Example 4, this one's my favorite, because this one here, you have to make 3 different equations, okay? Notice from 0 to 50 wristbands, okay, is this equation. But then from 51 to 100, let me actually use a different color for this, okay? From 51 to 100, you're using this equation. And if you're spending more than 100, you actually get a better discount. You'll notice this, by the way, when you are buying in bulk. The more that you buy, it's not that you're saving more, it's just you're spending less because you're buying more, okay? So you have to look at the different categories, okay? So no matter whatever you buy, that's where you're gonna place it. So let's say if I only bought 5 wristbands. I'm using this equation. If I'm buying 80 wristbands, I'm using this equation. If I'm buying 150 wristbands, I then am gonna use this equation. They're all crucial, and it all depends on what you are using essentially, okay? So what is the difference in cost between 1 order of 200 wristbands, 2 orders of 100 wristbands, and 4 orders of 50 wristbands each? There's a big difference, okay? Because it's 200, just 1 order of 200, okay? So 200, you're using equation 3, okay? For 100, for 2 orders of 100, you're using equation 2 twice, okay? But if you buy 4 orders of 50, you're then gonna use the first equation 4 times, because you're making 4 different orders. That 4 means you're making 4 different orders. That 2 means you're making 2 different orders. For the 200, you're only making 1, and that puts you in the more than 100 category. So the more that you buy in an instance, you're actually spending less essentially in this category. Essentially, okay? So here we go. That concludes the lesson. I'll explain this more if you pay attention in the lesson, but it's not difficult. The hard part, obviously, is understanding what you are doing. Good luck and Godspeed.